Okay, gang, my SD card died on me halfway through, so I'm going to explain what I did already. I'm going to re-explain it. So this is section 3.5, number 25. We're supposed to do this problem by implicit differentiation. So when I looked at this problem, I didn't like the format of this. If you like the format of this, then keep it. This would be 3 layers. The outer layer, the ln, the middle layer, the 2, the innermost layer, the y. And you could certainly do a 3-layered chain rule on this. What I chose to do was use my log properties to bring the 2 down in front. So that was, I just did a rewrite at the very beginning. And then after that, I started doing the derivative. So the derivative of this is 12x squared. The derivative of this is 2 times, this is a 2-layered problem, so 2 times these 2 layers. So derivative of ln is 1 over y, that's the derivative of the outer layer. The derivative of the inner layer is dy dx. Okay, so let me say that again. This is 2 layers. The outside's the ln, the inside's the y. The derivative of the outside layer is 1 over the inside. The derivative of the inside layer is dy dx. Okay, next part is this. Now, if this had been 2x, we would have just said it's 2, but it's 2y. So it's 2 times the derivative of y. So it's 2 times the derivative of y, which is 2 times dy dx. And then the derivative of 2x is 2. All right, so that's the derivative, the part in pencil. Now, the next part here is that if you have any fractions, you want to get rid of that, because what you're going to end up with is a complex fraction at the end. So now I want to get rid of this y. So I'm going to use the LCD. I'm going to multiply everybody by y, each term, so that I get rid of this y in the bottom. So if you notice here, I picked up a y. Here the y and y canceled. That's what I was trying to do. This guy picked up a y. This guy picked up a y. All right, so that's where I am. And also, if you notice, you can reduce everybody by a 2. So let's go ahead and do that, because that's just less stuff. So if I divide this by 2, this is a 6. This will go away. I'm just dividing everybody by 2. All right, which just makes the problem, it's less stuff floating around. All right, now I want to get my dy dx's on one side and everything else on the other side. So I'm going to move this guy over to the other side. Now, order doesn't matter. I could have put this first. What does matter is that you have the correct plus or minus in the front. Okay, so just make sure this one's negative and this is positive, but what order you put them in doesn't matter. All right, now I'm going to factor out the dy dx. Okay, so I factored out the dy dx. It's a common factor. Left with this. Now I'm just going to divide this off to the other side. Now this is perfect. You don't have to do anything more, but I just make a suggestion if you're interested. So this is perfect. That's fine if you leave your answer like that. It's a bit nicer since there's a common factor here to factor this out. Okay, and again, they might have the order slightly different in the back, like maybe maybe they have it as y plus 1. It doesn't matter which way you have it, but I'm just going to guess they probably have this reversed. And I'm only saying that because you see so much mathematics, like that looks more like formatted better than that one. It's like in descending order. They may have factored out a negative and put this in descending order as well. Okay, but this is fine here. If you factor out a y, that's nicer. And then as long as you have the plus or minuses in front of the terms correct, it's good. All right, gang, that's it for number 25. I'll catch you. Bye-bye.